So we are on question 5b. B1. Given the function f of x is equal to 1 minus 2 sine half x minus pi over 6. Find the amplitude, the period, the phase shift, and the vertical shift, and sketch its graph in the interval 0 to 2 pi. So you start with finding the mentioned properties. 1, the amplitude. This is the modulus of -2, which is 2. 2, the period. The period 2 pi over b. In this case, we are saying 2 pi over half. And this is the same as 4 pi. The phase shift, in this case, since the vertical is mentioned alone, here we mean the horizontal shift. So we equate this to 0 and obtain x is equal to pi over 6 divided by half, which is the same as pi over 6 multiplied by 2, so that we get pi over 3. Okay, the vertical shift, that is just the number standing alone, the 1. Okay, so we also find now, because now I want to start sketching, so we also need to find the scale. Remember, the scale is the period over 4 for functions sine and cos, sec and cosec. So the period here is going to be 4 pi over 4, in the scale, which is pi. So we're going to sketch the graph with that period. And with the scale pi, with the scale pi, so with the scale pi, the next 2 pi, the next 3 pi, and 4 pi. Remember, we've just been asked to sketch from 0 to 2 pi. So there's nothing much there. Okay, so this is sine with the amplitude 2, neg 2, and the shift 1. So we have 3 here, I mean 1 here, and neg 1 here. So for now, we're dealing with -2 and 2, and it's negative sign. So instead of it going up, because it's negative, it's going to go down to take care of the negative. So it will come down. I need to make it fully dotted. Okay, so it will come down. Within the required, this could go all the way up to there. But remember, we have to sketch it from 0 to 2 pi. That's also very important. From 0 to 2 pi. Okay. So we take care of the shift now. Horizontal shift. Pi over 3 to the right. So we add, from 0 we add pi over 3. So this point at 0, so I'll use a red ink. The point at 0 now will come at pi over 3. Then the point at pi will add pi plus pi over 3. So we'll get 4 pi over 3. So that took somewhere here, 4 pi over 3. The point at 2 pi will add. So we'll have 2 pi plus pi over 3. So we'll get 7 pi over 3. So it will move 7 pi over 3. So this point will move there. This point moved here. And so the graph will be coming this way. It is a bit difficult to do. Okay, so it will come, and then before we draw a line, let's shift the points. Okay, first we draw a line so that we're not much confused here. We can draw it in red, the same color. So we'll have a dotted line coming here, like that. Okay, then we shift now the dotted red line vertically. So from 0 to 1, and from there to -1, and from 0 again to 1, and then draw up to here, up to there. Here it could come dotted because we want to end from 0 to pi. So now we look for the extension on the left. Okay, so it means that on the left it could go as far as 2, because we would have shifted that point up to there and then shifted by 1. That's how it gets to be connected from 0 to 2 pi. A bit confusing. Alternatively, you can say, okay, this is okay, but I might have been confused. Say, could there be another method? Of course, yes. After you do all the table, then, after you do the properties, then you can come up with a table. You have to sketch from 0 to 2 pi, and so you know that you have to start from 0. You also know that if it was not reseated, yes, you could have completed the graph. You could have gone all the way up to 4 pi. So you pick 0, you pick pi over 3, the shift. You also pick pi. You also pick another shift, 4 pi over 3. And then you pick 2 pi, your ending point, so that you can know the corresponding values. So what will be f of 0? F of 0 will be 1 minus 2 sine negative pi over 6. Now this is the same as 1 minus 2, 1 plus 2 sine pi over 6. Remember, I mentioned at some point that sine is even. So when there's sine is odd. So when there's a negative inside the angle, the negative can come out. So it will make the negative 2 plus. So this is 1 plus 2 sine 30 is what? Sine 30 is half. So you have 1 plus 1, which is 2. And that's why we have this 2 here. And then you go to pi over 3. What will be f of pi over 3? That will be 1 minus 2 sine half pi over 3 minus pi over 6. So you can see that this is the same as pi over 6 minus pi over 6 is 0. So sine 0 is 0. So just remain with 1. And that's why we are at 1 here. What about pi? So f of pi is going to be 1 minus 2 sine pi over 2 minus pi over 6. That is 6 down, 3 pi minus pi, and that is 2 pi over 6, which is pi over 3. So you're looking for 1 minus 2 sine pi over 3. Sine pi over 3 is root 3 over 2. That is sine 60. So you get 1 minus root 3, which is in the negative. And that's why you can see that it's down. And you really don't know exactly what it is because it's a very small number there. That is 1 minus 1 point something. So it's negative 0 point something. So you also do f of 4 pi over 3. That will be 1 minus 2 sine. Remember there's a half here. So it will be 2 pi over 3 minus pi over 6. So 6 down, we get 4 pi minus pi over 6. That is 3 pi over 6, which is pi over 2. Sine pi over 2 is 1. So we have 1 minus 2, which is negative 1. And that's why this is at negative 1. And so for 2 pi, again, you won't know because it won't be a standard value there. So that's how your sketch would come out. So you choose which method to use.
Sorry, sir, I lost connection. I was failing to me. What are you solving for now?
For now, we're just saying alternatively, we could also use a table instead of using the graphs.
Oh, okay.
So we have found these values. We have found 2 here, and we have found 1 there. And here we found 1 minus root 3. And then the other one we found negative 1. So the other one we're saying again, we'll find something that you cannot quantify, that you cannot know as a quantity. So we can't call it full. We'll find it.
Sir,
Hello.
the vertical shift, how has it come to 2?
The vertical shift did not go to 2, it went to 1.
Now, at first you had to put it at 1, but now it's at 2. So I'm confused how you joined it to.
What is at 2 is not the vertical shift. What is at 2 is the extension of the graph to the given range. We are given that we should sketch from 0 to 2 pi. So what is at 2 is
Oh,
because of the 0 to 2 pi.
okay. Thank you.
So your graph will be the bold one in blue and not the dotted blue. This was somehow funny. If you're not careful, you can mess up on the numbers. Okay, let's go to 2. So that was B1. Did we make mention? Yes. To 2, prove that sec theta minus cos theta is equal to sin theta tan theta. So you start with the left-hand side. It's the one which looks complicated. So you say sec theta minus cos theta is equal to sec is 1 over, is 1 over sine, is 1 over cos, 1 over cos theta minus cos theta itself over 1. Common denominator will be cos theta. And then cos theta in cos theta, you get 1 minus 1 in cos theta, you get cos theta. Multiplied by cos theta, we'll get cos squared theta. But this will give us what? This will give us sine squared theta on top there over cos theta. Remember, this identity is coming from sine squared theta plus cos squared theta is 1. So you can split the sign there, that does a product, and then divide by cos theta, and the other one you can divide even by 1. So you see that the one dividing by 1 remains sine theta, but sine theta over cos theta becomes tan theta. This is the right hand side as required. So that's why I said it's easy to do identities always if you change everything to sine and cos. That is, if you have a mixture of sec, cos, sine, tan, cosec, sine, cos, cot, you always change everything else to sine and cos, and you're able to say that you'll get the answer easily.
So,
Hello?
I have a question. It says cos x over
Is to prove the identity.
1 plus sine. Yes.
It says
Cos x over 1 plus sine x.
cos
Cos x over 1 plus sine x.
yes,
Then plus 1 plus sine x over cos x equals to sec x. Okay, it's not really equals, but I don't know if it's approximation. There are 3 equal signs, so I don't know how you call it. Is it approximation or equivalent? I don't know.
it's just typo.
While there is equal sign. Oh, okay. Equal to 2 sec x.
So to prove this, you start the left hand side again. So the question was proof. So you say 1 plus sine x multiplied by cos x as the common denominator here Then you have cos squared x on top, because that will give you cos down, then multiply by the numerator, plus 1 plus sine x, and 1 plus sine x. And this will become what? Cos squared x plus 1 plus sine x plus sine x plus sine squared x over 1 plus sine x cos x. So that is equal to this plus that. You know what we get? We get a 1 from that identity there, and then plus 1 plus 2 sine x over 1 plus sine x cos x. Now 1 plus 1 will give us 2 plus 2 sine x over 1 plus sine x cos x. So 2 is common there, we factor it out, and we remain with this over 1 plus sine x multiplied by cos x. So you can see that this part and this part are going, so you remain with 2 over cos x, which you can write as 2 1 over cos x, so that you can see that 1 over cos x is sec x, and this is the right answer as required.
Thank you, sir.
Okay. Any other question on identities? You can spend some time here. If when you are doing anything, the tutorial sheet, when I sent on identities, this is the time to ask such questions. Don't tell me that everything that I sent there you understand. I can't believe that. Those things are not too easy to be understood in that manner. Are you going to ask? Mm. So, if you haven't watched, by the time you watch, would have moved. They are not a lot. They are not a lot. Not plus other courses. Maths must have its own timetable. And so during that timetable, that's where you watch. Okay, so we go to C. C. Solve each of the following questions. 1. 2 cos squared x minus root 3 cos x is equal to 0. So for x from 0, let's say equal to x, let's say equal to 360 degrees. So this was a nice question. Express your answers in degrees. Okay. So what do you do here? The first thing you do is to factor out cos. So you have a common cos. So it remains 2 cos x minus root 3 is equal to 0. Then what next? Is either cos x is 0 or 2 cos x minus root 3 is 0. And if that is the case, then cos x is going to be root 3 over 2. So we start with cos x is equal to 0. So cos x is equal to 0. What values of x will give us such? You start with 90 in here. So you only have 90 and 270. From the graph, of course, if you have forgotten the identities, the identical angles, which we call special angles. Then from cos x is equal to root 3 over 2, we have x is equal to, first you start with 30. Then from 30, remember, cos is like this. So when you say root 2 over 2, it's positive somewhere here before 1. So you have this value, which you have gotten there in the first quadrant. We have another value there in the fourth quadrant, where cos is positive. So what value will that be? You just say 360. You can do it somewhere. 360 minus 30, you get 330. So it will be x is equal to 330. And you call it a reference angle of that, of 30. So these are your solutions. So you are saying therefore x is 90, 270, 30, 330. That's how you get x.
So,
Mm-hmm.
I have a question.
Ask. Ask.
Sir,
Yes.
I lost connection. I'm just asking to repeat.
So we said this was an equation which has cos x here and cos x there. So you factor out cos x. You remain with 2 cos x minus root 3 is equal to 0. So either cos x is 0 or the other part is 0. If cos x is 0, then you are saying the angle that gives 0, the x angle that gives 0 will be 90 and 270. These are special angles. Then you go now to the second one, you solve for cos x, you get this root 3 over 2. Then from there, you look at which angles gives me root 3 over 2. The first one is 30. From 30, that is a positive angle. So again, you go in the fourth quadrant where cos is positive and use theta as a reference angle so that you get 330. That's all.
So,
Thank you, sir.
Okay. Mm-hmm.
I have a question. It says solve the equation tan x plus root 3 tan squared x equals 0. For 0 degrees is less than or equal to x less than or equal to 360.
Tan x
Plus root 3 tan squared x
is equal to 0.
Yes, for 0 degrees is less than or equal to x less than or equal to 360 degrees.
So using the same range, so you factor out tan x, you get 1 plus root 3 tan x is equal to 0. So it's either tan x is 0 or tan x is equal to negative 1 over root 3. So you look for the x value that gives you tan 0. So for tan x is 0, this is the same as looking for where sine is 0. So you have x is 0, x is 180, and x is 360. Tan will be 0 here because sine is 0. Then the next thing, tan x is equal to negative 1 over root 3. Tan is negative in the second and fourth quadrant. So first you look for tan x is equal to 1 over root 3. Why does that happen? That's on the so you check the special angles. So it's likely to happen at 60. Let's see. Sine 60 is 1 over root 2. Is root 3 over 2. So it's not there. It means that it's at tan 30. So x is 30. For tan x is equal to 1 over root 3. X is going to be 30. But what is 30 in the second quadrant? You say 180 minus 30, which is 150. In the fourth quadrant is 360. That's how you obtain your angles. Because when you say tan 30, this will be sine 30 over cos 30. So sine 30 is 1 over 2 over cos 30 is root 3 over 2. So this will be 1 over 2 by 2 over root 3, which is 1 over root 3. Then you take care of the negative by going by the difference in the second and the fourth quadrant.
Thank you, sir.
Okay, so let's log out and log back. We still have about 17 minutes. So we use 4 minutes to log in. 3 minutes to log, 2 minutes to log in, and 15 minutes for class up to 12. So let's do that quickly.